Now let's look at graphs of y is equal to a times the sine. Notice this time you have bx plus c, not just bx. Same thing here, bx plus c, and then you have plus d on the outside, okay? So what does this do? This creates a horizontal shift, and the d creates a vertical shift. All right, amplitude is still going to be the same as last time. Absolute value of a. Period still going to be the same as last time, 2 pi over b. Now we have some other stuff called the phase shift. Phase shift, and all they mean there is they mean like left and right, okay? That's going to be c over b, so you take that c value divided by b. You can have a vertical shift, and that's going to be d. If d is positive, you go up. D is negative, you go down. And then you have one cycle. I'm going to call this one cycle. One cycle is going to be given by, just like we did last time when we graphed these. It's going to be between 0 and 2 pi, like this. But you're going to put this argument this time. It's really the same thing that we did last time, bx plus c, but now you have the plus c in there, and you solve for x. All right, now, go ahead and learn how to find these things and so forth. And we're going to go to some examples here. First example, sketch the graph over one period. Sketch the graph. I'm going to put sketch graph over one period, Label points of any max and min. Label the points of any max and mins. Max and mins. And we're going to start out with part A. Part A is going to be y is equal to 4 times the sine of x plus pi plus 1. All right, let's see about sketching the graph of this. I'm going to start out just like I started out for the last examples. Amplitude is going to be the absolute value of 4, which is 4. The period, it's going to be 2 pi over b. Which part is b? The part that's being multiplied by x. Well, what's being multiplied by x is a 1 here, right? So period is 2 pi. What's due? The phase shift? I'm going to abbreviate that, phase shift. What's my phase shift? It's c over b. C is pi in this case, the part that's being added or subtracted with x. And b, y'all told me, was 1. Or I could say that's pi. What else? Vertical shift. Vertical shift is going to be what? 1 up. All right, just like last time, I'm going to say, okay, let's put this argument here, x plus pi, between 0 and 2 pi, including those. And let's solve for x to see where I'm going to draw that first period at. Well, if I subtract pi from both sides, I get negative pi is less than or equal to x, which is less than or equal to pi. So that tells me I'm going to draw my first period of this graph, or the only period I have to draw, between negative pi and pi. So let's see. Draw me a coordinate plane here. I'm going to call this pi. I'm going to call that negative pi on my x-axis. This will be my y-axis. And what's my amplitude here? 4. So I'm going to go up to 4 right here. Maybe I'll call that a 2. Maybe I'll say halfway is a 2 and not worry about, I better put 1 and 2 on this one. Maybe I'll put this and this, some tick marks there. Let me go down to negative 4. Call that -2, and I'll put some tick marks here and here. Now, what's halfway between 0 and pi? That'd be pi over 2. What's halfway between 0 and negative pi? Negative pi over 2. Now let's see, I have this 1, 2, 3, 4, broken into 4 equal sections, which I won't. All right, let's see. So if I draw this graph, I'm going to think of drawing this thing first, okay? 4 times the sine of x plus pi. I want to draw between negative pi and pi. So my sine function normally starts where? Right here? And it goes like that. Well, I have a phase shift, right? Of pi units. And actually, it's going to shift it pi units we could think of to the left. So I'm going to shift this pi units to the left right here. And my first point is going to start here instead of normally right there. If I shifted pi units to the left. All right, so starts there, sine function, and then it ends right here, right? At the end of that interval. What happens halfway between the left and the right endpoint in one period? There's another x-intercept, right? What happens halfway between these two x-intercepts of my sine function? Hits its highest point. And what's the amplitude here? Amplitude is 4. So it goes through this point, negative pi over 2, 4. So it's going to do something like this. It's going to do something like that. Then halfway between these 2 points, it's going to hit its lowest point of negative 4. And it's going to do something like that, one period of it. But we said for this particular function that we're trying to graph, so far this dash, let me write this. Y is equal to 4 sine, y is equal to 4 times the sine of x plus pi. But I need that plus 1 on it. So I need to shift that whole graph up 1 unit. Let's think about this. I shift up 1 unit. Instead of going through this point, I'm going to go up 1 unit. So I'm going to go right here. Where does that put me? A negative pi what? One, right? All right, what about this point? What if I go up 1 unit? Where does that put me at? Puts me negative pi over 2, comma, 5 instead of 4. How about this point? If I shift up 1 unit, I'm going to be here, right? How about this point? If I shift up 1 unit, where am I at now? I'm at pi over 2 what? I'm at pi over 2, comma, negative 3. And this point, if I shift up 1 unit, I'm at pi, comma, 1. So what does the graph I'm actually looking for look like? It looks something like this. Goes through that point, goes through that point, and it goes up like that. There is one cycle of it, and I labeled the maximum and the minimum of that. I labeled more than just maximum minimum, but at least I labeled that. How about B? B isn't beautiful. This stuff's beautiful, right? Well, maybe not. Maybe it's ugly to you. All right, y is equal to 2 times the cosine of 3x minus pi over 2 minus 2 like this. Let's look at sketching this graph. All right, let's see. What's our amplitude? Absolute value of 2, which is 2. What's my period? Period is 2 pi over b. So 2 pi over 3, right? Can't really do anything with that. It's nasty, but it's what I have. All right, what else did I need to look at? How about reflection? Do I have any reflection here? No, that's not negative. So maybe I'll put no reflection. How about my phase shift? Phase shift is what? C over B. I don't know. I don't need to put C over B. Shift is C, which is what? Pi over 2 over B, which is 3, right? What's that? Pi over 2 over 3 over an understood 1. So let's multiply by the reciprocal, write this as pi over 2 times 1/3. So I could write it as pi over 6 is my phase shift. How about my vertical shift? What's my vertical shift going to be? 2 units what? Down because of that negative. All right, so let's see. I'm going to need to figure out where do I put my first period. How do I do that? Take this argument here. 3x minus pi over 2. We're going to put it between 0 and 2 pi, and we're going to solve for x. What if I add pi over 2 to each side? I get pi over 2 is less than or equal to 3x, which is less than or equal to 2 pi plus pi over 2. What's 2 pi plus pi over 2? Oh, that's 2.5 pi, right? Or I could say 5 pi over 2. Now we could either think of dividing each one of these sides by 3 or multiplying by the reciprocal of 3, multiplying by 1/3. Multiplying by 1/3 here is easier. So you can do that in your head. You get pi over 6 is less than or equal to x, which is less than or equal to 5 pi over 6. So what does this mean? I'm going to draw my first period between pi over 6 and 5 pi over 6. All right, let's see. I need to draw me a coordinate plane here. X-axis, y-axis. Now, what's my amplitude? 2, right? But then I'm going to shift 2 units down. So I need to consider that. Here's 2. Here's -2. Let me go down to -4 since I'm going to have to shift 2 units down. All right, now let's draw this part between pi over 6 and 5 pi over 6. All right, we can break that in half, and we can break each one of these halves in half, right? What's halfway between these two? How would you find that? You would say what? 5 pi over 6 minus pi over 6 gives me what? 4 pi over 6, and you would divide that by 2. Or I'll tell you what, instead of divided by 2, let's take half of it. Well, 4 pi over 6 is what? 2 pi over 3 times 1/2. What do you get when you divide these 2's out? Pi over 3, right? So this halfway mark would be pi over 3 right there. All right, let's draw this function without the -2. We'll deal with the -2 in just a second, okay? Let's draw this function, amplitude of 2. It goes between here and here, we said, between pi over 6 and 5 pi over 6. And it's a cosine function. As an amplitude of 2, cosine function is going to start out right here. Okay? It's going to end right here. Halfway between those 2 points at pi over 3, it's going to take on this lowest point right here. Halfway between highest and lowest, x-intercept. Halfway between lowest and highest, x-intercept. So this function would do something like that. Oh, actually goes through this. But what are we going to do? We're going to take away 2 from this function. So we're going to shift everything 2 units down. So if I shift this point 2 units down, that puts me here. If I take this point, shift it 2 units down, that puts me there, right? This point, if I go 2 units down, 1, 2 puts me there. This point, 2 units down, puts me on the x-intercept. And this point 2 units down puts me on the x-intercept as well. So the actual function I'm looking for is going to look something like that. And let's label my minimum point here. What is that? Pi over 3, what? -4. How about this point? That's going to be 5 pi over 6 comma 0. And this point will be pi over 6 comma 0. And this is the function y is equal to 2 cosine of 3x minus pi over 2 minus 2. There we go. Just go through those steps each time. Don't shortchange it. Just go through those steps. Our last example. Our last example is going to look like this. Write a function of the form. Write a function of the form. Write a function of the form. Y is equal to a times the sine of bx minus c for the graph. For the graph. All right, they're not going to give you a graph with these directions here, okay? All this is gone because that's from the last example. All that's gone as well. Now let's suppose they give you a graph that looks something like this. With the directions, they give you a graph. This graph is going to go through negative pi over 6 comma 0. It's going to go through pi over 3, 5. So let me go ahead and call this pi over 3, 5. And this is not drawn to scale at all. It's going to go through, we'll call this 5 pi over 6. It's going to have an x-intercept at. So this function is doing something like this. It's coming down like this. It's going to go through also 4 pi over 3, -5. It's going to be right here, -4 pi over 3, -5. So it's going to do something like this. It's going to go through 11 pi over 6, 0 on the x-axis. Then it's going to have 7 pi over 3 comma 5. 7 pi over 3 comma 5. Going to go through that point as well. So it's going to look something like that. So they're giving me the graph this time, and I have to come up with the function. Let's see, I'm going to have to come up with a function to this form right here. Well, let's think about this for a second. What did taking the absolute value of a give you? The amplitude, right? So what would you say the amplitude is if I go from -5 to 5? That would be 5. So I could say it's like I have an a value of 5, right? So in other words, if I have an a value of 5, I can plug in 5 right now. Now, this boils down to finding B and finding C. How do we go about finding B and finding C? Well, let me ask you this. What is a period? Period's from here to here, right? Sine function goes all the way up, all the way down, and back to 0 over 1 period. So the period's from negative pi over 6 to 11 pi over 6. So how far apart is that? How long is that period? Well, the period is going to be 11 pi over 6 minus negative pi over 6. Well, that's 11 pi over 6 plus pi over 6, or what? 12 pi over 6. Or can I say that is 2 pi? So my period's 2 pi. And I find period as 2 pi over b. Isn't this how I find a period? 2 pi over b. So 2 pi over b will equal to my period, which we just said was what? 2 pi. So let's solve this for b, and then we have that b part right there, okay? What if I multiply both sides by b? Or, okay, you could do that, but what's the only thing you can divide 2 pi by to get 2 pi? 1. So b has to be what? B has to be 1 in this case. So what this gives me now is I have y is equal to 5 times the sine of 1 instead of b, x plus c. So now the only thing I need to find is c. Let's find c. What is c? My phase shift? Let's look at what my phase shift is here. Normally, my sine function does this, right? Something like that, goes back up and so forth. Starts at 0, 0 though normally. How much did I shift? I shifted what? Pi over 6 to the left. So if my phase shift is pi over 6, need more room here. Phase shift is equal to pi over 6. But what is my phase shift given by? It's given by c over b, right? So what is the phase shift? Pi over 6. So I can replace this part with pi over 6 is equal to c over b. But we just found b to be what? 1. So what is my c value? Pi over 6. So what does that give me now for my equation? Y is equal to 5 times the sine of 1x, or I could just say x, plus, what is my c value over there? Pi over 6. There is my equation I am looking for. It's the equation that they showed me in the graph of 5 times the sine of x plus pi over 6. That's just putting everything together. Good luck with the homework, folks.